This video is on trigonometry applications. Before watching this video, you should probably take a look at my video on trigonometry if you haven't already done so. We're going to be using those methods to solve word problems, essentially. A lot of the times you'll have to draw yourself a right triangle based on the premise in the problem. So let's take a look at what these say. So we have a 10-foot ladder is leaned against a building, and the base of the ladder forms a 35-degree angle with the ground. How far is the base of the ladder from the building? And it says round your answer to the nearest 10. So suppose there was a building here, and then there's a ladder that's leaned up against it. So that would be like, we'll say like that. Now they tell you that this would be the ground here. This is the ladder. All right, so it's the ladder leaned against the building. They tell you it's a 35-degree angle with the ground. So they're telling you this angle here is 35 degrees. All right, and they tell you that the ladder is 10 feet. So you know that this ladder, this length here, is 10 feet. So if you're comparing this to a right triangle, the right angle's here where the building meets the ground. And then you've got this angle of 35 degrees, and you have this 10-foot ladder that stays fixed. It's leaning up against there, right? And that's the hypotenuse, right? It's opposite the right angle. So they want to know how far is the base of the ladder from the building. This is the base of the ladder. How far is that from the building? So that's what I'm looking for, and I'll call that x. So what I really need to do is since I have a right triangle, I know an angle, I know a side, and I have an unknown side. I need to find a trig function that relates this unknown side and this side here when I'm using that angle. So what angle do I know? Well, the angle is 35 degrees, and this angle down here. What trig function relates this side here, which is adjacent to it, compared to the hypotenuse? So if I'm comparing the adjacent side and the hypotenuse, right, I'm going to use cosine. So it'll be the cosine of 35 degrees is equal to x over 10, the adjacent over the hypotenuse. And now you just want to solve this for x, which means, to solve for x, I'm going to multiply both sides by 10. And when I do that, I have 10 cosine of 35 degrees is equal to x. And then I can use my calculator to get an approximation. So 10 times the cosine of 35, we got 8.19, so it's round to the nearest tenth, so we're going to round that up to 8.2. So x equals, this is going to be 8.2. What are the units on it? Well, the ladder was in feet, so this other side would also be in feet. Make sure you put units on there. So x equals 8.2 feet. Right? Now, if you wanted to find the height that the ladder reaches up the building, then this would be your unknown side, because you still do the same type of thing. You just have to use the sine because it's the opposite over the hypotenuse. Let's take a look at another example here. So we have a plane takes off at an angle of 15 degrees with the runway. When it is 800 feet above the ground, vertically, right, so straight up and down, find the distance the plane has flown directly from takeoff to the point at which it is in the air. So it might be helpful if we draw this, this way you have an understanding of what they're asking you here. So, you have a plane and it's taking off. So here's the runway. It came up the runway this way and it's taking off and it ends up over here. So here's your plane, in the air. We're saying that it is 800 feet above the ground. So it's 800 feet above the ground here. It took off at an angle of 15 degrees. So it came up here, took off at an angle of 15 degrees with the runway. So it says when it's 800 feet above the ground vertically, find the distance the plane has flown directly from the takeoff point to the point at which it's in the air. So we're looking for this distance here. So I'm going to call that x. Recognizing that this is a right angle here where the plane is vertically above the ground is at a right angle. And so again, this is a right triangle problem. We have to be able to draw it. So if I'm trying to find this distance here, I'm really trying to find the hypotenuse. So I want a trig function that relates the angle I know with a side I know and the side I'm trying to find. Well, in this case, 15 degrees is my angle, and then the 800 is opposite that. So we know the opposite, we're trying to find the hypotenuse. Which trig function relates opposite and hypotenuse? Well, that's sine. So you want the sine of 15 degrees. Remember, it's always of the angle that you have here, is equal to the opposite, which is 800, over the hypotenuse, which is x. Now we just want to solve this. To solve this, remember, you have to get x out of the denominator first. So I'm going to multiply both sides by x. So I have x times the sine of 15 degrees is equal to 800, because these x's cancel. And then we want to divide by the sine of 15 degrees. Divide by the sine of 15 degrees. So you get x is equal to, or approximately, it says round to the nearest tenth, so we're going to do 800 divided by the sine of 15 degrees. Make sure your calculator's in degree mode. And we got 3090.96. That 6 will round that 9 up to the next decimal will be a 0, and then it's going to be a 1. So 3091.0 feet. Right, that's what's rounding to the nearest tenth. So the plane is flown 3091.0 feet. Keeping in mind that, we rounded this, right? That's an approximation. And, they could ask you the same type of question, but they might ask you, find the horizontal distance the plane traveled, which would be this, rather than the point from takeoff to where the plane is. But if you knew this 800 feet and you didn't know what this side was, then you'd be comparing the opposite and the adjacent, and you'd be using tangent for your trig function. Last example here. This is from the top of a lighthouse 190 feet high. The angle of depression of a boat at sea is 34 degrees. Find the distance from the boat to the base of the lighthouse. So let's draw it. So here's a lighthouse here. All right, and this is, they tell us it's 190 feet high. So I know this is 190 feet up and down. And the angle of depression, making sure you understand what that means. The angle of depression really means, if you were up here in the top of the lighthouse and you were looking out straight at the horizon, the angle of depression is the angle looking down. So it's this angle from the horizon to what you're looking down at. And then here would be, the boat. So this angle of depression is 34 degrees. The angle of depression is measured from the horizontal. So it's measured downward here. Now, that's the angle of depression. But that's not part of my triangle, right? The triangle I formed is here. I've got this right angle here at the base of the lighthouse with where the water is to the boat. And, this is my right triangle. I know this side's 190 feet high, but I don't have any angles in the triangle right now. There's a couple ways you can figure this out. You could say that, okay, I know this is a right angle here, and I could do 90 minus 34 to find that piece. The other thing you could do, which is, the more common way to look at this, is that the angle of depression is going to be equal to this angle of elevation looking up from the boat. This is also 34 degrees. So the angle of depression equals the angle of elevation. If you're looking up from the boat, the angle between the horizontal and looking up is 34 degrees too. So it's the angle of elevation. Now you should know these are equal to one another. If you remember back from previous algebra classes, if you have two parallel lines like this horizontal and you cut them by a transversal, opposite interior angles will be congruent, will be the same, will be equal. So that's what we have here. So a couple ways you can find this. You could also figure out that this has to be 66 degrees, or I should say 56 degrees, based on taking 90 minus the 34, and then using that as your way of finding that angle. But angle of depression is equal to the angle of elevation, so we know that this angle here is 34 degrees. So if we're just using strictly what we have, what's it asking us to find? It says find the distance from the boat to the base of the lighthouse. So here's the boat to the base of the lighthouse. I'm looking for this distance here. Well, which trig function relates an angle we know here with the opposite is what we know, and the adjacent is what we're trying to find. Well, what trig function uses opposite and adjacent? Well, that would be tangent. So we want the tangent of 34 degrees is equal to the opposite, which is 190 feet, over the adjacent, which is x. And again, if you want to solve this, you have to get x out of the denominator first. I'm going to multiply both sides of this by x. And I get x times the tangent of 34 degrees is equal to, x is canceled here, 190. And then we're going to divide by the tangent of 34 degrees. Divide by the tangent of 34 degrees. Make sure you're showing your work here and how you get this. And you get x equals 190 divided by tangent of 34 degrees. And we get 281.68. So that 8 will round to the nearest tenth, so we'll round that 6 up to a 7. So we get 281 0.7. What are the units? Well, this was measured in feet, so this will be feet. So the boat would be 281.7 feet away from the lighthouse. So it's key to understanding the angle of depression is that it's not part of the triangle. It's actually from the horizontal, you're measuring down 34 degrees, but that's the same as the angle of elevation looking up from the boat. So you'll see questions like this, and it's easiest if you can remember what angle of depression, angle of elevation mean. But the angle of elevation, it's already in the triangle here because you're looking at it from the boat looking up. So hopefully these examples, help show you how the word problems are set up. Most of the time you have to draw a picture, and then from there use the right triangle you've drawn to find the piece they're looking for in combination with the trig functions that, have an angle that you know, a side that you know, and a side you don't know. Because that's how you're going to actually solve for the side we're trying to find.